here comes multiplication and division of surds. Simplify root 60 times root 180 over root 75. Solution. In this kind of example, we are going to look at someone who doesn't have calculator, how to go about this surd. Because if you have calculator, simply you can multiply the numerator and combine it together. Remember our product and division rule. As these are now, they can equally be stated thus 60 times 180, and whatever value you have over root 75, and you can further say that this whatever it gives you, you can still combine it together as your division rule will suggest. Okay, now, but since probably you don't have calculator, or you are not allowed to enter with calculator, how do you go about this kind of exercise? Okay, now you look at this. This is 60. What are the factors of 60? Of which one of it? Two factors of 60 rather. Of which one of it will be a perfect square? Now, if you look at it closely, you can see that 4 is a factor of 60. 4 divided 60 will give you 15. Okay, so you have root 4 times 15 times now 180. What can be a perfect square that can divide this 180? Now, if you look at okay, if you look at 36 can divide this, and if 36 divide this, we are going to have 5, right? 36 times 5, because this times this will give you 0, this times this is 15. 15 plus the 3 will give you 180. Okay, so this is root 36 times 5 all over root 75. Okay, now from here you can say that this root 4 times root 15 times root 36 times root 5 all over root 75. Okay, now from here root 4 is 2 root 5 root 15 rather. 2 root 15 times 6 root 5 all over 75. Root 75, sorry. In this 75 we have 3 and 25 times root 3. Okay, now with this 25 is now 5 roots 3. Okay, now from here now we can have it that this times this 2 times 6 is 12. We have 12. Remember this is products. The product rule, you can multiply together the surds. Now with this we have 5 times 15 will give you 75. So we have 75 all over 5 root 3. Okay, now this can as well be stated thus 12 over 5 times 75 over 3, all in roots. Now 3 into 75 will give you what? 12 over 5 times this will give you 25. Okay, 25 root 25, and root 25 is 5. So now 12 over 5 times 5 cancel here, we are left with what? 12. 12 is the final answer. I believe you understand that. Okay. Now we're going to look into other things, or rationalization of Surds and other things, so that we can digest Surd very well and move to other topics. All right. Okay, rationalization of Surds. Now, the essence of rationalization is to remove the denominator that is Surd. When the denominator is Surd and the numerator is a rational number. For instance, if you have x over root y, okay, your concern is to remove this root, this irrational number from the denominator. Now, when you want to do that, you employ this root y over root y. You multiply it out so that you eliminate these roots from the denominator, okay, and move it probably to the numerator side, okay. Now, remember what we discussed during our conjugation of sorts. So we are going to employ more of that in rationalization. So we are going to have some examples to illustrate that. And as soon as we are done with rationalization, we move over to other topics. Okay? So stay tuned. All right, the following says, simplify the following sorts. We have the first one, 4 over root 5 plus root 3. And the second one, 3 over 2 root 6 minus root 3. And the third one, 1 over in bracket 1 minus root 3, all raised to power 2. All right, now solution. Let's take the first one, 4 over root 5 plus root 3. This simply we employ the conjugation of this denominator. And remember, the conjugation is 4 over root 5 plus root 3 times root 5 minus root 3 all over root 5 minus root 3. Okay, whatever you have up, you have it down as well. Okay, from here now you multiply out. You start with, from the numerator side, you say 4 times root 5 is 4 root 5 minus 4 times root 3 is 4 root 3. Okay, now over root 5 times root 5 is 5 raised to power 2. Okay, or simply let's just make it write it out immediately, because okay, let me explain it anyway. Root 5 raised to power 2, okay, minus okay, this now times this, we have minus root 5 times 3. Okay, and then this plus 3 multiply 5, where we have plus root 5 times 3. Okay, then plus root 3 times minus root 3 will give you minus root 3 raised to power 2. Okay, all right. Now when you look at this now, you can return this, the front, or you can return the front one, because their sorts are not the same. Okay, they are not similar sorts here. Now, so you still have 4 root 5 minus 4 root 3 all over this raised to power 2. That's this root 5 raised to power 2. Simply means that this 2 will cancel this root. Now you are left with what? 5. Okay, that's what this can cancel this. Okay, so that's what I want to explain here. Now you find out that here is minus root 5 times 3. Then this one is plus root 5 times 3. So this will cancel each other. Okay, now you are left with what? This root 3, this one will cancel this. Okay, now you are left with what? Minus 3. Now from here, now we can say equal to root 4 root 5 minus 4 root 3 all over 5 minus 3 is 2. Okay, now if you look at this, take it one by one. Probably you say 4 root 5 over 2, okay, minus 4 root 3 over 2. That way you can cancel this 2. You cancel this one, cancel here 2. So you can have 2 root 5 minus 2 root 3. All right, so looking at this now, you can say that this 2 is common here. You can simply bring it out from the bracket, bring it out of the bracket, and you have this root 5 minus root 3. Okay, ladies and gentlemen, that's the final answer to this sort. Okay, this is the answer. All right, stay tuned while we bring you the answer to we bring you the second example. Okay, let's prepare the board, so stay tuned. Okay, all right, the second example, we have 3 over 2 root 6 minus root 3. Okay, now you can still have 3 over 2 root 6 minus root 3. Now, what is the conjugate of this? You can simply say times 2 root 6 plus root 3 all over 2 root 6 plus root 3. Okay, this is the conjugate. So you have the conjugate, you have it to multiply the expression up and down with its conjugate. Okay, now from here you can say 3 times 2 is what? 6. 3 times root 3 times root 2 3 times 2 root 6 is 6 root 6. Okay, do you understand it? This is more concerned about what? About the number outside. Okay, that's what you are multiplying. Okay, because this is just simply saying 3 times 2 root 6. Okay, now whatever you have outside, we multiply each other with your common irrational number, which is root 6. Okay, now we have 6 root 6 plus 3 times root 3. We have 3 root 3. Okay, now coming to here to this one, we have this times this, we have 4. Now, because we have two irrational numbers here, they're going to multiply themselves. We have this times this, we simply give you 6, because they will end up having root 6 times root 6. You have root 6 in brackets squared. Okay, and this square will cancel the root. You are left with what? 6. So 6 root 6 times root 6 is what? 6. Okay, now coming to this, we also say 2 times 1. Here you still have what? Plus 2. Now 6 root 6 times root 3, we have 18. Okay, now from here too, we say minus root 3 times 2 root 6, we have minus 2 root 18. Okay, now we also move to this side, we say minus root 3 times root 3. Here we have minus plus is minus. We have what? 3 times root 3 times root 3. Here will give you 3. Okay, straight hand. All right, now from here, now we can say 6 root 6 plus 3 root 3. Okay, all over Now, this times this is what? 24. And looking at this, they are the same. I mean, they can cancel each other. This has plus, this has minus. So you can cancel them. You now have minus what? Minus 3. Okay? Follow me. Now, from here now we can have 6 root 6 plus 3 root 3 all over 24 minus 3 is what? 21. Okay? Now, we can go ahead and break it again. And we can have that 6 root 6 over 21 plus 3 root 3 over 21. 3 can go here, 7. If it goes here, we have 2, okay? Now, 3 can go here, 1. If it goes here, we have 7, okay? Now, from here, we can have it that 2 root 6 over 7 plus root 3 over 7. All right, so combining it, we now have 2 root 6 plus root 3 all over 7. This is the final answer, okay? The final answer. All right, so stay tuned. Let's bring the third example here. There is something we need to explain there, okay? All right. Okay. Let's look at the third example. The third example says 1 over 1 over 1 minus root 3 in bracket all squared. If you look at this is a perfect square. Okay. Now, what you do to it, you say 1 over. This is 1 minus root 3. 1 minus root 3. That is, you represent it into 2 different places, okay? Now, from here, you can say equal to. Now, when you multiply out, we're going to have 1. 1 times 1 here is 1. 1 times root 3 here is minus root 3. Okay? Now, minus this root 3 times 1 here too, we have minus root 3. Okay? Now, this root 3 minus root 3 multiply itself. We have plus 3. Remember, minus times minus is what? Plus. And root 3 times root 3, meaning that we have root 3 raised to power 2, okay? These 2 we cancel roots. We are left with 3. So that's the 3 we have here, okay? Now we continue. We say 1 over 1 plus this 3 is 4. We have 4. Now minus root 3 minus root 3. We have minus 2 root 3. What does that mean? You know that the number standing out here is 1. Okay? But in mathematics, it's not written, okay? So you say minus 1 will give you minus 2. So that is minus 2 here. And they have the same surd, root 3, okay? Now from this, now you can take the conjugate of this number will give you times, because the surd is still at the denominator side. Remember, the essence of rationalization is to remove the surd at the denominator side of any fraction. Now from here we can say 1 over this, then the conjugation of this is 4 plus 2 root 3 over 4 plus 2 root 3. Now we say 1 times 4 is what? 4. So we have 4 here, and 1 times this is still itself 2 root 3 all over, right? Okay, at the denominator side, we have 4 times 4 here is what? 16. And 4 times 2 root 3 here, we have plus 8 root 3. Okay, now for this we have minus 2 root 3 times 4, we have minus 8 root 3. Okay, now we also have minus 2 root 3 times plus 2 root 3. Remember, minus plus is what? Minus. So we have 2 times 2 is what? 4. And 3 times itself is still in root 9. Okay, so from here now we move to the other side. We have 4 plus 2 root 3 all over. This is 16. Okay, we have 16 here, and we're looking at this we cancel each other. Okay, now we are left with this and 16. Now this is just simply saying minus 4 times 3. Okay, remember root 9 is what? 3. Now from here we move down, we say 4 plus 2 root 3 over 4 times 3 is 12. 16 minus 3 minus 12 is 4. Okay, so we have 4 here. Now distributing them, we have 4 over 4 plus 2 root 3 over 4. So here we cancel this, then 2 1 2 2. So this will give us 1, this 1 here plus root 3 over 2. So this is our final answer, 1 plus root 3 over 2. Okay, all right, thank you. We have many other examples on this, but if you feel that you don't understand any particular one, always call our attention so that we can put you through the comment section. Okay, we are going to enter into index notation and functions in our next class. So this is where we end the operation with Surds. Thank you.